This is example 2 of lesson 4.5 input-output tables. I'm over here now, by the way. And we're talking about Jennifer, who has a kitten. So cute kitten. She got a kitten for her birthday, and the kitten weighed 1 pound when she got it. It's a tiny little kitten. Every week, the kitten gained 0.5 or half a pound. The weight of the kitten, or y, can be found using the function 1 plus 0.5x, where x is the number of weeks she's had the kitten. So, if we look here at our input-output table, we see that we have our input, which is how many weeks she has had the kitten. We're going to plug that number through this function, which is 1 plus 0.5x, and we're going to get the kitten's weight without having to weigh the kitten, assuming the kitten is gaining a steady 0.5 pounds per week, which for this example we are. So, we have our vending machine function here. We're going to plug in our x values into our function, and we're going to get out a y value. And we'll talk about the graph here in a minute. So, our function, 1 plus 0.5x, we'll plug in 1 first. We'll have 1 plus 0.5 times 1. 0.5 times 1 is, well, 0.5 plus 1 is 1.5. All right. 1 plus 0.5, and I'm not putting the 0 there to conserve space. 0.5 times 2 is 1, plus 1 is 2. 3, 1 plus 0.5 times 3. 0.5 times 3 is 1.5, plus 1 is 2.5, etc. 1 plus 0.5 times 4, that's 2, plus 1 is 3. I can count. And 1 plus 0.5 times 5. 0.5 times 5 is 2.5, plus 1 is 3.5. 0.5. Are you noticing a pattern here? Pattern here. What pattern do you notice between these numbers? So if I was to change color here, for example, and talk about what happens here, what happens here, what happens here, and what happens here, it goes, well, it goes up by 0.5. Every time. And that has to do with how many times we're multiplying the 0.5. And we'll get more into function rules looking at what happens to functions and function rules later. But for right now, let's go ahead and talk about this graph here. We are going to graph our points. Wait, you have what, points? What points? We don't have points? Yeah, we do have points. We have x values and we have y values. We have x values here. And we have y values here. All we need to do is pair an x value, and that's a terrible square, pair an x value with a y value. Oops, I lost a 5. All right, so this first pair, 1, 1.5, that would be point 1, comma 1.5. So let's graph that. Over 1, up 1.5. And yes, you can graph decimals on a point. It's just halfway between. 2, comma 2, x is 2, y is 2. Over 2, up 2. Remember, always go over to the right first and then go up. As long as it's positive, you go to the right. Then we have 3, comma 2.5. Over 3, up 2.5. Bam. Over 4, up 3. Over 4, up 3. And lastly, over 5, up 3.5. All right, now I'm going to erase my points here because they're kind of in the way of looking at this graph. The x value represents time, so how many weeks have passed, and I could label that on my graph if I so chose, which I do. This is weeks. And the y is weight. It's hard to write sideways, which is in lbs for pounds. So every week it looks like it's going up half a pound. What do you notice about this graph? Well, they're all in a straight line. That's interesting, isn't it? It's going up steadily each time. We'll look more into graphs later, but for now, we plugged our x into our function and got a y. We matched our x values with our y values and got points to graph on the coordinate plane. And that's it. Awesome kittens.